Okay, welcome back. So today I have this fun, this amazing problem where you have n as a positive integer, and you look at all the a's mod n such that n divides a to the n plus 1. And you would like to, no, I'm rejecting that, shut up. Yeah, you'd like to find how big a n looks. So, let's see. I guess I should start by doing the smallest prime thing, right? So a to the n minus 1 is minus 1 mod n. Oh, okay, let p dividing n be minimal. I'm gonna try to show p is 2. I think that's probably what's gonna happen. So a to the, let's say a to the n is minus 1 mod p. Shout out to Matthew from ReVT. So a to the 2n is 1 mod p. So order of a mod p. But let's say assume p is greater than 2. So the order of a mod p now divides 2n. But it should also divide p minus 1. And that's contradiction. So necessarily n must be even. So smallest prime is 2. Now if I do this same argument again with the second smallest prime, haven't I done this problem before? Hang on. I'm like, wait, this thing's really familiar. So it's the same, it's no, it's slightly different. This problem, you have the property for every integer a. But I want it for, yeah, I want it just for us, like some integers a. Anyways, okay, so n has to be even, and if I do the same dance mod 3, yeah, now I'm confused. So like 2 works. Does 4 work? 4 doesn't work, right? Does like 6 work? 6 should work. Right? No. Okay, n is even, so in particular it's a sum of squares. Of squares and it should be a sum of squares, and consequently only one mod 4 primes can be in. Only one mod 4 primes can be in there. How does it divide to it? Because p is the smallest. Oh, sorry, I thought this is the smallest prime trick. So if it's the smallest prime, then it can't divide 2n or p minus 1 until this p is the shit. Oh wait, I'm being stupid. I'm sorry! Oh, frick. 3 works. What am I doing? That equals 3. You're like 2q plus 1, right? Oh, Jesus Christ. Shame on me. Okay, so n is either even or a multiple of 3 if an is non-empty. So if 3 works, then powers of 3 should work as well, right? Wait, I'm messing something up. Something is definitely wrong. Like, why can't I just... If n is odd, can I take a equals n minus 1? Thank you, Ninja Nerdbird, for the follow. Wait, hold up. Alright, I think I'm being stupid. Alright, rewind! Everyone back up! Back up! Alright. That's not how orders work. No. 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 Stop. If n is odd, take a equals... Wait. People don't know what hurt in confusion means. Ignore everything I just said for the last like 10 minutes. That's all garbage. And also only 1 mod 4 primes. So something like 2 times 5 will work. Does something like 2 times 5 times 31 work? It ought to, right? Yeah, by using primitive roots, it should be okay. You want -1, so... You need v2 of p minus 1 greater than v2n? Really? Why? No, you can't have... Oh, you can't have big v2 because, like... then 4 divides the sum of 2 squares, one of which is odd, and that's not good. So I think by primitive root argument, for all other remaining primes, should be okay. An is non-empty for all of these. Yeah, because like for example, suppose if you're looking, so explicitly modulo p to the e, we pick well really you just pick any let I be a square root of -1 and force n to be congruent to I mod p. And n is like twice an odd number, so yeah, things are just fine. Okay, so that settles that. As for evenness, how are you supposed to do even? Okay, as for evenness, so when n is even, pairing implies an is even. When n is odd, the number of solutions to a to the n is congruent to -1 mod p to the e. For odd prime power p to the e, it is what? It must be odd, right? No, I don't think it depends on the parity. It's odd because a equals -1 is a solution. A equals 1 is not. And any other solutions come in pairs. A comma 1 over a. Okay, 2/3 done, 2/3 done. No, Putnam did not win the vote, sorry. Okay, so now the question is, can it equal 130? Okay. I don't get your solution to A. Is there a part you want me to elaborate on? Yeah, the 130 is a big, like, meme. Okay, so when n equals 2p, how many solutions are there? That should be... two. Not very good. Let's try 2pq, alright? Let's see. If n is 2pq, how many solutions are there? So modulo, it's the product of number of solutions modulo p and this number of solutions modulo q. Shoot. Hang on. So the number of solutions to a to the n is congruent to -1. No, this is always odd. How come it's different? No. No, it's not. It's always even. For every prime power, the number of solutions... In the n even case, this is always an even number, right? Because the solutions come in pairs a and 1 over a. By the same logic. Also by pairing. Okay, so actually... something's weird. For n to equal 130, n can only have one prime power, right? Because otherwise it's divisible by 4. So if n has more than one odd prime factor, distinct odd prime factor, then an is divisible by 4, and that's no good. So for 130, pay attention to only n equals 2 p to the e. However, number of solutions to this should be pretty easy to compute. We want the number of solutions to a to the p to the 2p to the e is congruent to minus 1 mod p to the e. The second part is wrong. Wait, what? Wait, what did I screw up? Is it like n equals what, 2 or something? Here? Or did I make a bigger mistake? What's my answer to A? The answer to A is any odd number, and also any even number with exactly one factor of 2 and only 1 mod 4 prime factors. Okay, anyways, where was I? Okay, so cycles, we have a primitive root of order p minus 1 times p to the e minus 1. So there are 2p to the e minus 1 solutions. Is that right? Did I do that calculation right? Should be the GCD of them, right? I think so. Okay, that's fine. So is C just no? I don't see how you're possibly going to get 2 times 5 times 13 out of like 1 prime. Unless I missed something. Probably for the question. Alright. Okay, any objections? Does this look good? Did I mess anything up? Okay, cool. I'm calling this done. Okay, let's write this up. Okay. Should not both need that. Even numbers in A other than n equals 2. Okay. Oh, is Armo local today? Did Evan solve this? Yes. Okay. 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 Let's post on AOPS. I think people enjoy watching this happen for some reason. Okay, we also have we can also post the VNum problem now, right? I don't remember where I saw it.